In this lesson, we explore what is meant by odds. We start with odds against an event. What we must understand is that the odds given at, for example, gambling venues are usually given as odds against winning, unless they are otherwise specified. Odds against winning. So the definition for us for odds against an event is it's a ratio. It's a ratio of failure to success. It's the ratio of the probability that the event will fail to the probability that the event will occur. This following formula may be used to determine the odds against an event. So it is a ratio, so it's a fraction, the probability of failure to the probability of success. The probability of the event failing to occur divided by the probability of the event occurring. For example, determine the odds against rolling a 4 on one roll of a fair die. Now, before we can determine the odds, we must first determine the probability of rolling a 4. In other words, the probability of success. Now, and also the probability of not rolling a 4, failure. All right, so when you're rolling a die, a fair die, we know that there's 6 possible outcomes, right? 1, a 2, rolling a 3, rolling a 4, rolling a 5, or rolling a 6. So this is how we're going to do it. To get us started, let's figure out the probability of rolling a 4. Okay, now we know the probability of rolling a 4, there is one favorable outcome out of 6. So that's the probability of rolling a 4. Now let's figure out the probability of failing or failure to roll a 4. Now, for failure to roll a 4, we know that there are 5 ways we can fail, right? We can roll a 1, a 2, a 3, a 5, or a 6. Those are 5 different outcomes, right? 5 different ways we can fail out of 6, of course. So we know what our probability is of success. It's right here. And the probability of failure is here. Now that we know those probabilities, we can now figure out the odds against rolling a 4, okay? Now, according to our formula, the odds against rolling a 4, in the numerator, I need to have my probability of failure, so that is 5 over 6. In the denominator, I need to have my probability of success, which is 1 over 6. So remember how to divide by fractions. We keep the first fraction the same. We change division to multiplication, and we reciprocate the second fraction, which means we just kind of like flip it over. You can multiply straight across if you'd like, and then you should simplify. I prefer to cross cancel. So 6 goes into itself once, and 6 divided by 6 is 1 as well. And so now I multiply straight across. So 5 times 1 is 5 over 1 times 1, which is just 5. So this is the ratio. And there's different ways of writing this ratio or even saying it. So we can write it as, this is common right here, 5 to 1 with a colon like that. And it's read as 5 to 1. So therefore, the odds against rolling a 4 are 5 to 1. 5 to 1. Those are the odds against rolling a 4. Now, I hope you see that these denominators here, this denominator 6 and this denominator 6, canceled themselves out, right? And so what you're left with is 5 in the numerator here. 5 was the number of unfavorable outcomes. Unfavorable, right? Ways we can fail. And what we were left with in the denominator was a 1. 1 is the number of favorable outcomes, right? Actually rolling a 4. And so anyway, there's a way we can simplify, or there's another way to find odds against an event. If all of the equally likely outcomes of an experiment are already known, then the odds against an event can be determined without calculating probabilities. So there's another way we can determine odds against an event, and it's like this. In an experiment with equally likely outcomes, the odds against event E can also be determined using this formula. In the numerator, you have the number of outcomes that are unfavorable to E over the number of outcomes that are favorable to E. Okay? And so remember the answer of the previous problem was 5 to 1. That was for rolling a 4. How many outcomes are unfavorable to rolling a 4? 5, right? Remember that? We could roll a 1, a 2, a 3, a 5, or a 6, right? Those are unfavorable outcomes. Over how many outcomes are favorable to rolling a 4? Well, there's only 1, right? And so 5 to 1. So that beats having to do this, folks. 5/6 over 1/6, and then doing the arithmetic, 5 over 6 times 6 over 1. Then the 6's divide out, and you're left with 5 to 1. This way here, hold on. This way is faster. All right, cool. But just keep in mind, this shorter way can be used as long as you know all of the equally likely outcomes of the experiment. Although odds are generally given against an event, at times they may be given in favor of an event. Now, when the odds in favor of an event are expressed, they're expressed as a ratio, and it's the probability of success to the probability of failure. All right, one card is drawn from a standard 52 card deck. Determine the odds in favor of selecting a queen, and then determine the odds against selecting a queen. Okay, first of all, the odds in favor of selecting a queen. Think about a standard 52 card deck. How many queens are there? 4. There's a queen of spades, a queen of clubs, a queen of hearts, a queen of diamonds. There are 4 queens. So the probability of success, well, let me rewrite this. The odds in favor of selecting a queen will be, we have the probability of selecting a queen in the numerator and the probability of not selecting a queen in the denominator. Okay, so what is the probability of selecting a queen? Well, say equals. There are 4 queens in the deck out of 52 cards total. This is the probability of selecting a queen. Okay. Now, how about the probability of not selecting a queen? Well, if there are 4 cards that are queens, that means there are 48 cards that are not, right? Or, so you can do 48 over 13. Or, if you'd like, you can do 1 minus 4 over 52. Remember that formula? If this is the probability of an event happening, then 1 minus that probability is the probability of the event not happening. All right, let me move this up a little bit. All right, cool. So 4 over 52 is equivalent to 1 over 13 if you simplify. So then this is equivalent to 1 minus 1 over 13. Just divide 4 and 52 by 4. 4 divided by 4 is 1. 52 divided by 4 is 13. So this fraction, 4 over 52, is the same as or equivalent to 1/13. Okay, anyway, so then this is equal to 1/13 over 12/13. 1 whole minus 1/13 is 12/13. So then this is 1/13 times 13/12. And so you see, hopefully, that these 13s divide out. And so the odds in favor of selecting a queen are 1 to 12. 1 to 12. 1 to 12 are the odds in favor of selecting a queen. Now, let's save ourselves some work here, everybody. If 1 to 12 are the odds in favor of selecting a queen, let's see, there we go. Then the odds against selecting a queen is just the reversal, so 12 to 1. Okay, that saved us a lot of time, okay? So I'm going to make a statement here. So we're done with this problem. I'm going to make a statement here, and I think it's really good for your notes. If the odds against an event are A to B, then the odds in favor of the event are B to A. So it's just opposite, all right? That should save us some time. Now, just like before, we do have a shortened formula for the odds in favor of an event, okay? So here's our formula for when we have equally likely outcomes. The odds in favor of an event, in the numerator you'll have the number of outcomes that are favorable, in the denominator the number of outcomes unfavorable. For example, the probability, or not the probability, the odds in favor of selecting a queen earlier, remember the answer was 1 to 12. So using this shorter formula here, the number of outcomes favorable to E, favorable for selecting a queen, remember there's 4 queens, and the number of outcomes unfavorable to selecting a queen, that means there's 48 cards in the 52 card deck that are not queens. And if you simplify this, then you get 1 to 12. So it's just shorter work. It's less arithmetic. Now, what we can do is we can determine probabilities from odds. So when odds are given, either in favor of or against a particular event, it's possible to determine the probability that the event occurs and the probability that the event does not occur. So remember, when we have odds against or odds in favor of an event, that's not the same thing as a probability of an event occurring or a probability that the event does not occur, okay? So we want to be able to figure out a probability given the odds. Now, this is what's key. The denominators of the probabilities are determined by adding the numbers in the odds statement, okay? The numerators of the probabilities are the numbers given in the odds statements. Okay, that might sound confusing. Let's look at an example, and I believe after the example, it'll all make sense. All right, the odds against Amy being admitted to the college of her choice are 9 to 2. Determine the probability that Amy is admitted. And then we'll figure out the probability that Amy is not admitted. All right, first of all, they gave us odds against being admitted. Remember that odds against something, odds against an event, is the probability of failure over the probability of success. So we have the probability of failing to be admitted over the probability of being admitted. And they told us that this ratio is 9 to 2. Okay, so these are the odds. This is what's given to us. Okay, I just want us to make sure, I want to make sure that we understand what the 9 represents and what the 2 represents. Okay, so since the odds statement is 9 to 2, that means the denominators here, right here, up here, folks, the denominators of the probabilities are determined by adding the numbers in the odd statements. Okay, so we have 9 and 2 in the odd statements. Therefore, the probability of success and the probability of failure both have a denominator of 9 plus 2, which is 11. All right, so now we know the denominator. To get the odds ratio of 9 to 2, the probabilities then must have been, hold on, let me move that up a little bit. So the probability of failure, well, they gave us the odds against, right? The odds against. And so the odds against is a ratio of failure to success. That's what odds of against means. Odds against means it's a ratio of failure to success. So that means 9 is the failure and the 2 is success. So therefore, the probability of failure must be 9 over 11. And the probability of success must be 2 to 11. All right. So once again, they gave us odds against Amy being admitted as 9 to 2. In order to get the denominators of the probabilities, I just had to add these two numbers. And so the probability of failure is 9, the first number, because they gave us odds against. That means the probability of failure to success. So 9 over 11 is the probability of failure, and 2 over 11 is the probability of success.